In this video, I'd like to continue talking about sinusoidal functions from their equations, and I'd like to look at it more generally, since in previous videos, we looked at how to determine the amplitude, the distance from the midline to either the peak or the valley from its equation. We've also learned how to determine the midline, the line that essentially cuts the function in half horizontally from its equation. And we've also looked at determining the period from the equation, where the period is essentially one unique oscillation of our sinusoidal function, and then this will repeat infinitely many times. And if we write out the equation generally, we can have y is equal to a multiplied by the sine of b times x plus c, and then plus d on the outside, where A would be related to the amplitude. And let's classify all these. We can say actually that the absolute value of A is the amplitude. If it's negative, it doesn't actually affect this vertical distance here. It will just reflect the function over, and that vertical distance will still be the same amount. And in the previous video, we looked at B. That deals with our period, though actually the formula for our period is a little bit more complicated. It's 2 pi divided by the absolute value of b. So the bigger the value of b, the more squished this function becomes. And if b is negative, that doesn't actually affect the period, since negative values multiplied by our independent variable on the inside of our function will just reflect the function about the y-axis, but won't actually interfere with the length of the period. And C, we haven't talked too much about, but we will cover in a later video. C deals with the phase shift. Actually, it's a little bit more complicated. So for now, I will just say this deals with a horizontal shift. It will move the function left or right, but depending on what B is, that affects this horizontal shift as well. And lastly, we had D, adding a number on the outside or subtracting. This will cause a vertical shift. If it's positive, it moves it up. If it's negative, it moves it down. And this graph right here, we know is the parent function for the sine of our angle x. And we've seen it has an amplitude of 1. Its midline equation is just y equals 0. Let me do that in a darker color. And remember that midline essentially just cuts the function in half horizontally, and the amplitude is the distance from that midline to either the peak or the valley of our sinusoidal function. And the period, one complete oscillation, is 2 pi. And we can see that it goes up through the peak, down back through the midline, then through the valley, and back to the starting point. We can see that one unique oscillation is 2 pi. And all of this would be true for the cosine of x. It would have the same amplitude, midline, and period, since remember that the cosine of x is really just the sine of x, but shifted pi over 2 radians. That has to deal with this value c if everything else was either 0 or 1, 1 for a and b, d is 0. Then if c is pi over 2, that will shift the function to the left pi over 2 radians, and we would get the cosine function. But again, the main point is that the sine and the cosine are really the same function, they're just shifted relative to each other. So for instance, the general way to use this equation, let's say we have an example. If we are told that y is equal to minus 2 multiplied by the cosine of 3x plus 4, we can determine the amplitude, period, and whether or not there's any shifting. Now, looking at the amplitude, we can do that first. The amplitude here, I'll just write a and p, that's the absolute value of a. And since a is negative 2 and we take its absolute value, we just get a positive 2. Now, dealing with period, we have our b value. This is a, this is b, and our d value is 4. But when dealing with period, we take this value and we put it in the denominator for this fraction here. So we have that the period is 2 pi over the absolute value of b, but b is a positive number. So our period is 2 pi over 3. Or another way to look at it is that it is 1/3 of the period of our parent function. And lastly, we don't have any horizontal shifts. We're not adding on the inside, but we do have a vertical shift. And our vertical shift is just 4 here. We're going up 4. So let's just say our vertical shift is positive 4. And if we want, we can use this information to actually construct a picture, starting with the parent function for the cosine function, using the fact that we're doing a reflection about the y-axis. The amplitude will be stretched up by a factor of 2, but then we'll be reflecting over this x-axis. And again, this is the sine function, not the cosine, and we're dealing with cosine here. But you can get a general idea. Then for the period, we will essentially just squish the function. We will divide the period by 3 from the original parent function, and then shift everything up 4 units. And that will give us the graph of this equation here. And to get a better understanding of this, it's useful to look at this using a computer graphing program. So in the next video, we will look at this general equation, but on Desmos.